Today we are solving the LeetCode problem called first bad version. So I'm going to explain the full code for the solution in C++ and then we're going to run it for the test cases and ensure that we pass all of them. So here they are describing a situation where you are a product manager and you're trying to find the first bad version that impacted the development process. Well, they kind of set it as a storyline here, but basically they are saying, suppose you have n versions of your products from 1 to n, and you want to find out the first bad one, which causes all the following ones to be bad. Assume that you have 5 versions, and the first bad version was 4. This means that version 4 here is bad, obviously. Version 5 is also bad because 5 follows 4, and the first bad version affects all the subsequent ones, and version 3 wasn't affected yet, so that one is a good version, so we return false. In case there is only one version, for example, and that version is bad, then we return that version. There are going to be billions of values. In this case, the array can have billions of values. So here they're already giving us this function like an API, and they say it's already defined for us. So we can simply call isBadVersion, that is a function, and pass it one of the versions that we want to query or that we want to check, and we're going to get true or false if it's a bad version. So we only need to work on this function called firstBadVersion, and we don't need to implement this one because it's already provided for us in the background. So now let's look at my solution here. In this case, again, when I run it, it performed well. I am using logic that is very similar to binary search logic. So here we have our function, firstBadVersion. It is taking an integer parameter called n, that is the n number of versions that we have. And first I'm setting left to 1, which is the lowest value according to the constraints of this LeetCode problem. And I'm setting right to n. The next thing here, I'm setting middle also to left, just to assume that at first the middle is the left one, which is the earliest version, is the bad version. It doesn't matter so much because we're going to update this value anyway. Then I have this last found variable, which is set to 0. Now 0 here is outside of the constraints of this problem. You can see that the version started at 1, but I'm setting this to 0 because at first we've not found or confirmed that we found a bad version. But we're going to use that to record the faulty version as we process our array of versions. So first we're checking, is it the leftmost version that is the bad one? If yes, then I'm going to set last found to the left. So the index is going to be 1. Otherwise, if it's the right, then we're going to set the right to the bad version, that is going to be n at first. And this whole loop, by the way, is going to run until the left crosses the right, meaning this left pointer is not a pointer as in a memory address, but a pointer as in an arrow that we use to explore or traverse our array. So this left pointer here must not cross the right, right? So long as the left is less than the right, we can still continue with this logic here. So this is very similar to binary search, like I said. Next thing is we try and get the middle between our left and right range. The range from the left all the way to the right, it's an inclusive range. We try and get the middle points within that range. And then we check if the middle is also a bad version, the middle point. Wherever the middle is pointing to, we want to check if it's a bad version. If it is, then we're going to record this version, the middle version, as the first bad version. Okay, we're using last found here, meaning the last value that we recorded as the bad version. Now, if the middle is a bad version, it means that the first bad version was somewhere around the left, okay, somewhere towards the left. So then we set the right to middle minus 1 because now we want to eliminate half of our current range and search towards the left. Otherwise, if the middle was not a bad version, we want to set the left from middle plus 1 so that we can start searching now from middle plus 1 all the way to the right. That is going to be our new range. And by the end of this algorithm, which is a logarithmic algorithm, last found is going to hold the value of the first bad version. Now, I need to point out that this code can actually be optimized because you see here, for example, I'm saying if the left pointer is pointing to a bad version, then set last found to left, that is fine. And then here I'm also checking if the right pointer is pointing to a bad version. Technically, if we found left, which is most likely less than right, so if the left is a bad version, we don't care about what is on the right. We only care about what is on the left. So we need to concentrate towards the left in our array and ignore the right. But in this case, you can see that I'm having this if statement here, and then I'm also having this if statement there. So you can actually optimize this to go through fewer steps in this algorithm, but I'm going to leave this as homework for you guys and let me know how you optimize this in the comment section. I'm going to leave my code as is because, like I said, this is based on binary search, so it's a logarithmic algorithm, meaning that it's very fast. Even if we have billions of values, we're only going to have dozens of steps to search through our array. So this is just fine. I don't need to optimize it too much. And by leaving it like this, it's very similar to the classic binary search algorithm. So it's easier to understand, especially if you are new to programming. So anyway, that's it for the entire explanation of my code. I believe it's the same one as this here. To prove that it works, let's just click on run code. We've passed this test case, and now I'm going to submit, and I think we should pass everything. So we just did, and it was fast enough, 4 milliseconds. So that's it for this LeetCode challenge called First Bad Version. If you like my solution and my C++ tutorials, please subscribe to my channel, and I'll catch you next time.